Hey everybody, instead of having class today, I made this video so that we could review polynomial long division, synthetic substitution, and synthetic division. Okay? If you've never seen this before, it will seem rushed, and if you don't remember anything about how regular long division works, it may also be extra confusing, but hopefully I'll be clear enough that you'll be able to pick it up regardless. So, I'm going to start right away with this example here on my Bright Link, and we're going to divide x squared plus 10x plus 21, and we're dividing it by x plus 3. Okay? Hopefully you remember how long division works, where you write what you're dividing by on the outside and what you're dividing into on the inside. And I'm suddenly thinking maybe I didn't leave enough room for where the answer goes, which is on top. So my first question, kind of like regular number long division, is what would I multiply times x to get x squared? And the answer is I would multiply x by itself, by x to get x squared. So I'm going to write that up here. I'm going to choose to keep my place value theme going and put the x over the 10x. And now I'm going to multiply this x by x plus 3. I only use the first term to decide what to multiply by, but then when I multiply by that factor, I have to distribute it through everything that I'm dividing by. So I'm going to take this x and multiply it by x plus 3, which gives me x squared plus 3x. Now, I'm really picky personally about one thing, and that is I always write parentheses at this step. If I don't write these parentheses before I move on to the subtraction step, I will mess up. Maybe you can do it without it. That's up to you. So the parentheses are there just to remind me to distribute this subtraction, which is the next step of long division, both the x squared and the 3x. So x squared minus x is 0. That was the whole plan. We asked ourselves, what do we multiply x by to get x squared, just so this would go away. And now we ask ourselves, what's 10x minus positive 3x? And that answer is 7x. Then we bring down the plus 21 for our next step. And we ask ourselves the same sort of question, but now we're asking ourselves, what would you multiply x by in order to get 7x? X times what gets you 7x, and that's what we write up here on top, again aligning the place value. And now, even though we only looked at the x in figuring out what to multiply by, when we do multiply, we have to distribute the 7 to the 7x and to the 3. Again, if I don't use my parentheses, I'll mess it up. I got a 0 remainder. Just like with integers, if you get a 0 remainder, then you have two factors that go evenly into the original polynomial. In other words, what we've just learned is that if we multiply x plus 3 times x plus 7, and we FOIL, we'll get x squared plus 3x plus 7x plus 21. Hey, look kids, we just double checked. We got our 10x in the middle. Awesome. Okay, so that's what happens when you get a 0 remainder. In fact, this was kind of a silly way to do this problem. Most of you should have been able to look at this and go, oh, 21 at the end, factors, 10 in the middle, 3 times 7 is 21, 3 plus 7 is 10, but sometimes it's good to start with an easy one that you could have done a simpler way. Let's go on to one that's a little bit uglier. And now, first thing I'm going to do, because again, this is like integers and place value is important, I'm going to rewrite what we're dividing into as 6x cubed minus x squared. Notice that this minus sign in front of the x squared travels with the x squared. Don't make that mistake. Minus 5x plus 4. 4 is positive here. Has to still be positive when we rearrange the order. And that is being divided by 3x minus 2. Okay, same set of questions as last time. first thing we do is ask ourselves, what would you multiply 3x times in order to get 6x cubed? I would choose 2x squared, which would get me 6x cubed. Now, even though I only look at the 3x to determine what to multiply by, I still have to distribute, and that gets me minus 4x squared. Once again, if I don't write parentheses there, before I even write my minus sign for the next step, I will mess up that step, just me personally. So now, the 6x cubed minus the 6x cubed is 0. Good, that was the plan. The negative x squared minus negative 4x squared, well, that's like a plus, so that should get me 3x squared here. Next step, bring down the minus 5x, and then ignore the minus 5x for a moment as I to ask myself, what times 3x would get me 3x squared? So it'd also be a good time to notice that I really didn't do a good job up here of sticking to my place value alignment, but I'm going to do a better job now. Okay, so again, I'm asking myself now, what times 3x would get me 3x squared? Answer would seem to be a positive x. And I multiply that positive x times the 3x, I get 3x squared. But I also have to distribute it times the negative 2. So that's minus 2x. Once again, my parentheses. And now 3x squared minus 3x squared, 0. Good, all going according to plan. Negative 5x minus negative 2x becomes addition. So that leaves me with negative 3x. And now, let's find a color I haven't used lately. Purple. Won't clash at all. Okay, bring down the plus 4. And now I ask myself, what times 3x would get me negative 3x? And that would be minus 1. Multiply the minus 1 times the 3x, get negative 3x. Distribute to the minus 2 and get plus 2. Subtract, and it looks like I'm going to get 0, 4 minus 2, 2. I have a remainder of 2. So here's what we learned. 3x minus 2 times 2x squared plus x minus 1 does not equal 4 minus 5x minus x squared plus 6x cubed. These are not divisible factors of this polynomial. So we have a remainder. Let's give myself a little more room here. But what we did learn is that if we wanted to, and there's some reasons in future classes why you do want to, if we wanted to, we could rewrite the fraction 4 minus 5x minus x squared plus 6x cubed divided by 3x minus 2 as 2x squared plus x minus 1 plus 2 divided by 3x minus 2. Remember that trick when something didn't go evenly into a larger number back with integers many, many years ago? So if you were looking at, 21 divided by 8, it goes into it twice. And 2 times 8 is 16, so that remainder is 5. So you put the remainder over the denominator, over what the original denominator you were dividing by. Same thing for polynomial long division. We put the remainder over the original denominator, the original thing, factor, that we were dividing by. Okay, hope that made sense. Let's see. Oh, this one I included because these get tricky sometimes. So here's what's tricky about this one. We have our 6x to the 4th plus 5x cubed plus, wait a minute, we skipped one. We don't have, I love it when it does that, hang on, little alignment issue here. We don't have a squared term. We skipped from cubed to x. Now in polynomials that's okay. In integers, like we talked about, that's not. You have to have something representing the hundreds place. This is literally why the Hindus invented 0. So I'm going to put a 0x squared in there, in between the 3x and the minus 5, just to account for my place value. And now I'm going to divide by 3x squared minus 2x. Okay, so now I'm going to ask myself, what would I multiply by 3x squared that would get me 6x to the fourth? And the answer would seem to be 2x squared. So 2x squared times 3x squared does get me 6x to the fourth. And once again, I have to distribute. 2x squared times 2x would get me minus 4x cubed. Okay, cool. So now, parentheses, minus sign, 0, good. 5x cubed minus negative 4x cubed gives me positive 9x cubed. Okay, so now I'm going to bring down my 0x squared. Here's where that gets important. And now I'm going to ask myself, what would I multiply 3x squared by that would get me 9x cubed? And the answer is plus 3x. If you're really sharp-eyed, you may have noticed that for all my talk about place value, I'm doing a terrible job of remembering to align the numbers, the terms above the division sign. So it's not actually vital if you do that. You can still get it right without doing that, but it definitely looks better. So now we multiply the 3x times the 3x squared, and that gets us the 9x cubed, which, was the plan. And then 3x minus 2x gets us minus 6x squared. Here's where that plus 0x squared could becomes very important, because the 9x cubed minus the 9x cubed, that's the 0 as we planned. But now we have 0x squared minus negative 6x squared. So a positive 6x squared is my next term that I have to deal with. So now I'll bring down the plus 3x, and I'll ask myself, what times 3x squared would get me 6x squared? And the answer is just plus 2. So 2 times 3x squared is 6x squared, and 2 times negative 2x is minus 4x, parentheses, subtract, 6x squared minus 6x squared is 0, 3x minus negative 4x is 7x, and we stop because we don't have anything left to bring down. Whoops, yes we do, one more. Wait, I wish. Went past here. I need to pick another color. We'll use the sort of rainbow space dust color here to bring down the minus 5. That's cool. But 3x squared, I don't really have anything that I can multiply 3x squared by to get 7x. So I'm thinking maybe that's a good place to stop, call up my remainder, and ask myself, what did we just do? Well, what we did is we figured out that this division problem has an answer that can be written as 2x squared plus 3x plus 2 plus 7x minus 5 over what we're dividing by originally? 3x squared minus 2x. Okay? Hopefully that's clear. Kind of like my color patterns here. Anyway. Okay, so now we're going to look at when can we talk about using what's called synthetic division, which is a great shortcut under certain circumstances. And those circumstances depend on what you're dividing by. If you're dividing by what's called a linear binomial, okay? Linear because it starts with a linear term, looks kind of like mx plus b, and then just has a constant term, binomial, 2 terms, nothing else going on. So another thing is that leading coefficient has to be 1, okay? And it's usually written in the form x minus c. Okay? In fact, usually you don't see the 1, you just see x minus c, but it has to be 1x, can't be any other coefficient. The minus is there as a reminder to flip this sign. Okay? It's a little bit like those counterintuitive shifts. You know, whenever something's snuggled up with x inside a function, it means shift it the opposite way you'd think. Well, that means we're going to be flipping this 2 when we start our synthetic division. We're going to put a negative 2 here and make our synthetic division operation symbol like that. And then all we're going to use are the coefficients of the polynomial that we're dividing by. So instead of 5x cubed, I'm just writing 5. Oh, there's no x squared here again. We're skipping that one. So I have to put a 0 there, okay, to just symbolize, to hold the place. Well, to hold the place, it's a placeholder. These are like integers. This is literally why the Hindus invented 0 thousands of years ago, just for this purpose. I can go ahead and put a 6 for the 6x, put the 8 there, and this is to represent 5x cubed plus 0x squared plus 6x plus 8. Okay, have to put the 0 there. Now, when we start with this, okay, what we have is, well, first thing we do is we just look at this first coefficient, and all we do with that is bring it down. Don't change it, don't do anything else, just bring it down. Then we multiply that first coefficient by this negative 2 here. So negative 2 times 5, that gets me a negative 10. Then I add this column. 0 plus negative 10 still leaves me with negative 10. Now I multiply negative 2 times this negative 10, giving me positive 20. Again, I add the numbers in this column, giving me positive 26. Now negative 2 times positive 26 gives me negative 52. 8 plus negative 52 leaves me with 44. Okay, that's a neat little quick trick to generate 4 random seeming numbers in a hurry. What do these numbers actually mean? Well, when you divide something to a polynomial of the 3rd degree by a polynomial of the 1st degree, okay, your answer is going to get dropped down 1 degree. So what these new numbers tell us is that our answer to the question, what is 5x cubed plus 6x plus 8 divided by x plus 2, the answer is 5x squared, starts 1 degree lower because we divided it by something in the 1st degree. It's like when you divide, 100 by 10, you get 10, you just drop down 1 place value, minus 10x, keep going down the degrees, plus 26, we're out of things, we can't go past 26, so what we can do though is take our remainder. That's what this last bit is. That is our remainder, and that remainder becomes the numerator of a fraction with what we were originally dividing by as the denominator. So this is the answer to the question. If you divide 5x cubed plus 6x plus 8 by x plus 2, remembering to switch the negative 2, switch the sign on the x before you start your synthetic division, you'll get 5x squared minus 10x plus 26 plus a remainder of 44, which will become the numerator in a fraction with x plus 2 as its denominator. Let's try that again, see how quick we can get at it. Okay, we are dividing by x plus 2 again, cool. Means I'll write a negative 2 there. Now, we have a 1. Once again, we don't have an x squared, so we put a 0. That 1 is for the x cubed. We have a minus 7 for the 7x. Minus 7x, we have a minus 6 for the constant term. So this again is for our 1x cubed plus a 0x squared minus 7x minus 7. Just change it to these coefficients and bring down the 1. Multiply by negative 2, add to this column, still get negative 2. Negative 2 times negative 2 is positive 4. I'm now going to get minus 3. Negative 2 times negative 3 is positive 6. I have a remainder of 0. Okay, this factor went in evenly, neatly, no remainder whatsoever. So I now know that x plus 2 times, notice what I did there? Took this x plus 2 factor here. It's negative 2. Rewrote it as x plus 2. And if I multiply this times a new polynomial with these coefficients starting 1 degree lower from cubic, because that's what we started with, I will get x squared minus 2x minus 3. And multiplying those two together gets me x cubed minus 7x minus 6. This could be an excellent factoring trick because this cubic, looking at it, I have no idea that it could be factored by anything evenly. I had no idea if it could be factored at all. It could have been prime for all I know. But now I know, with the x plus 2, that it does have not even like even odd, but like factors that are polynomials, okay, no remainders. And it looks like this last bit can be further factored to x minus 3, x plus 1, because that would get me, if I double check, x squared minus 3x plus 1x minus 3. Yep, combine those two middle like terms and I would get that original like term. Yes, so this can be further factored. So we didn't have to do that. The directions were use synthetic division to divide by. So I got a little carried away. Actually, all I needed to write was that my answer was x squared minus 2x minus 3. But one of the reasons I got a little carried away there is because next thing we're going to be doing is using synthetic division to factor. Now, synthetic division has one other powerful use, and it is called synthetic substitution, and it's based on what's called the remainder theorem. And here's how it works, okay? If you're looking at a polynomial like this, and you plug in, you use 2 for your, okay, let me start over this explanation. If you're staring at this polynomial and you want to know what f of 2 is, you can plug 2 in here and ask yourself, well, what's 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3? And for some of you, that may be the fastest way to do it. But another thing you can do is you can check to see if the factor x minus 2 goes in evenly, and if it doesn't and you get a remainder, that remainder will be the same thing as if you plug 2 in. In other words, here's what I'm going to do. I'm going to write 2 here, okay? The 2, there's no switch now. If you're using synthetic substitution to find a value, you don't switch. If you're using synthetic division to get an answer to a division question between polynomials, then you do switch the sign. But this 2 stays positive 2, and my coefficients are 1, negative 4, they finally put an x squared in there, we don't have to put a 0, 5, 3, and now I just bring down the 1, 2 times 1 is 2, negative 4 plus 2 is negative 2, 2 times negative 2 is negative 4, 5 plus negative 4 is 1, difficult math here, but it's actually really easy to mess up. 2 times 1 is 2, 5, okay, according to this, if I were to plug 2 in for x in that original polynomial, I should get 5. And you just know, we're going to have to double check this now, right? All right, so 2 cubed is 8 minus 4 times 2 squared plus 10 plus 3, which is 8 minus 16 plus 10 plus 3, which is negative 8 plus 10 plus 3, which is 2 plus 3, which is 5. Get the same thing either way. Personally, I'm a little faster at synthetic substitution. And if you get something like to the 5th or 6th or 7th degree, I think it's a lot easier. But you don't want to rush it too much. It is faster, that's its advantage, but you don't want to rush it. It's real easy to make mistakes with the positives and negatives here. We'll do one more synthetic substitution example, and that is we're looking for f of negative 4. So again, since it's synthetic substitution, we do not switch the sign. If we were doing synthetic division and they gave us a binomial to divide by, x plus or minus a number, then we would switch the sign. But if you're just plugging in for synthetic substitution, we don't. And my coefficients are 3, 4, -5, and 3. Again, can't stress this enough. This comes from 3x cubed minus 4x squared minus 5x plus 3. All right, let's get going here. Switch up the colors a bit. Bring down the first coefficient. Cool, the 3 is there. Now, -4. Oh, that's not what I meant to do. Okay, -4 times 3 is -12. Add these and get -8. Multiply those and get +32. Add those and get +27. -4 times 27 should give me -80 plus 28, -108. So -105 is what I'm getting. So f of -4 equals -105. And if you want to let me know that you really watched this video when you're done, email me. Double check this last one. Tell me that I got it right. That's your check-in for watching this video. Well, plus doing the homework tonight. Email me if you have any questions. I'll either answer them in class on Thursday or I will make another video like this. Isn't it amazing how even here in my classroom you can hear the chinchilla from the middle school way down the hall? Wow, that's a loud chinchilla. If you listened carefully earlier, you might even have heard my dog bark all the way from Gaithersburg. All right, guys, have a wonderful rest of your day. Be safe. Hope to see you soon. Bye-bye.